There we go. Okay, so today we are doing our last lesson over transformation. So, a transformation is an operation that makes an original image called the pre-image that maps an original figure called the pre-image, which we talked about this last class a little bit. The original's the pre-image onto the new figure called the image. Remember, we used primes for the image, and the ones that don't have the primes, which is the apostrophes, that's called your pre-image. On the graph to the left, triangle ABC is the pre-image, and triangle A prime, B prime, C prime is the image. So my original is triangle ABC. Once I've made the transformation, it's A prime, B prime, C prime. A transformation can change the size, the position, and the orientation of a figure. Now, last class we changed the size, okay? We did not have congruent figures. We had similar figures. We changed the size. So what is a rigid motion? A rigid motion is when a transformation preserves the size and shape of a figure. All corresponding sides and angles of the pre-image and image are congruent. So, last class we did non-rigid motions that did not preserve the size. Okay, that's whenever we used a scale factor. Okay, and that was called our dilations. Today we're going to do rigid motions, which are going to preserve the size. So all of our figures are going to still be congruent to each other. Examples of rigid motions are translations, reflections, and rotations. So those are the three we're going to look at today: translations, reflections, and rotations. So the first one we're going to do is a translation. A translation just means that you are going to vertically and or horizontally slide a figure. And the way our coordinate notation looks for this is my point P, which is XY, would then become point P prime by doing X plus H, comma, Y plus K. So it tells you what to do to the X value to get the new X values, and what to do with the Y value to get the new Y values. Okay? So the H represents your horizontal shift because it's being added to the x is your horizontal variable or asymptote, so that's your horizontal shift. And k is the vertical shift. Just like I said last class, guys, when we were doing our dilations, on your test, are you going to be given the coordinate plane? Yes. Do you have to use the coordinate plane? No. What am I actually grading? The graph? No. But the ordered pairs. Okay, I'm grading the ordered pairs. We are going to do a couple of these where, yes, we are going to plot them, and then we are going to transform them and write the new ordered pairs. Then we're going to do some where we're not going to use the graph at all, and we're just going to write the new ordered pairs. Okay? So, looking at this first one, let's plot our points. -6, -1, and that is point Q. -3, 1, that is point R. 1, -5, and that is point S. And then -2, 7, -7, sorry, and that is point T. And draw your rectangle. Okay. So, it says my points are all x, y, and then I'm doing x plus 5, and then y plus 7. So let's start with point Q. If I'm adding 5 to the x, would that mean I move it to the right or to the left? To the right. Positive numbers are to the right. So let's go 1, 2, 3, 4, 5 points to the right. And then my y value says y plus 7, so I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. And that's my new Q, or my Q prime. So I went right 5, up 7, and that gives you your Q prime. Now that ordered pair now is -1, 1, 2, 3, 4, 5, 6. So -1, 6. So let's pretend we didn't even use the graph, guys. Okay? Q was at -6. What's -6 plus 5? -1. I was at -1, but then I add 7. What's -1 plus 7? 6. So do you see how you don't even have to use the graph? We could just look at the ordered pairs, add 5 to the x value, and add 7 to the y value. But we're going to use the graphs for the first two. So go to point R. We're going to go 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5, 6, 7 up. And that's your R prime. That point is at what? 2, 8. Good. Then let's go to point S. 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5, 6, 7 up. And that ordered pair then is where? 6, 2. And then my last one, 1, 2, 3, 4, 5, 5. And then 7 up, 1, 2, 3, 4, 5, 6, 7. And that's your T prime. What's that ordered pair? 3, 0. Guys, is my rectangle the same size? Yeah, it was just moved. Okay, that's what a translation is. You're not changing the size. You're not changing the orientation. Side QT is still on the left side. Side QT. Side RS is on the right side. Side RS is on the right side. We did not change the orientation. We just changed the location. It went from the bottom left to the top right. Good? Okay, so let's do one more like this. Plot your 3 points. 2, -1, 7, -4. And then 4, -6. And draw your triangle. So I'm going to take point C, and it says I'm doing what with my x values this time? Subtracting. So is that going to shift me right or left? Left, because negative numbers are to the left. And then my y is going what? Up 8. So left 3, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8. And that's your C prime. Then D goes left 3, 1, 2, 3, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Then E, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Make sure you put your primes for your image. Okay, so let's write those ordered pairs. What is C prime at? Negative 1, 7. What's D prime at? 4, 4. What is E at? Good? Do we all feel like we could do this without now graphing them first? Yeah. Okay. I think it's actually easier to not graph them. Okay? So, I'm just going to look at my J's x value, which is negative 4. And what am I doing with the x values? Adding 2. So what's negative 4 plus 2? Negative 2. Comma. Let's do it in this color. 7. And what am I doing with my y values? Subtracting 2. So 7 minus 2 is 5. Then let's go to K. The x value is 0. What am I doing with the x value? Adding 2. So 0 plus 2 is? And then 8 minus 2 is? L prime. Negative 1 plus 2 is? 4 minus 2 is? Then negative 5 plus 2 is? 3 minus 2 is? Do we think that was faster and easier? Yes. Do you have the visualization, though, to see if you did it right? You do? I don't see anything on the graph. No. But you could graph them and check. To save time, we're not going to because we're doing a lot today. Okay? So my x value is subtracting 7. So 1 minus 7. Am I doing anything with the y value, guys? No, y stays y. So it's just 7. Then x prime, what should x prime be at? Negative 1 what? 5. What's y prime going to be at? And what is z prime at? Good? This one, it's missing part of it. It should say the rule, which is xy becomes x minus 1, comma, y minus 5. If it just tells you the ordered pairs of the original and doesn't tell you how to translate them, you can't really go anywhere. So you need the rule. This is the rule. Okay? So what's my s prime going to be at? Negative 5, negative 3. What's my t at? 4, negative 6. And what's my u at? Negative 3, negative 7. Then number 12, it's also missing the rule, so this is xy goes to x plus 4, comma, y minus 1. Y'all do this one on your own. Do number 12 on your own. Guys, do you need parentheses around the ordered pairs? Yes. Yes, if you don't put parentheses around the ordered pairs, are you going to get it right? No. Nope, I'm counting it wrong because it's not an ordered pair if you don't have parentheses around your ordered pairs. Okay, what's A prime, guys? 1, 5. What's B prime? What's C prime? And what's D prime? Good? Okay, now we're going to have both images and we're going to write the rule. Okay? The biggest thing you have to make sure that you do is identify which one's the pre-image and then which one is the image. If you start at the wrong one, you're going to get it wrong. Okay? So we always start at the pre-image, which is the ones without the prime. Do I have to try all the points, or just like when we did our scale factor, can you just use one of the points? One. Do we want to do D, E, or F? D. Okay, so D. My rule's going to be XY becomes X. What am I doing with my X value? It went 7 to the right. So if you go 7 to the right, you are adding 7. Then the Y is going up 4, meaning what? Plus 4. There's your rule. Okay, same for this one. X comma Y becomes X. Okay, make sure we're starting at the right image. Which point do y'all want to use? What? M. Okay, so 1, 2, 3, 4 to the left, meaning I subtract 4. And then Y, I go up 2, so plus 2. Are we good with writing the rules? Okay. Are we good with translations? Okay, now we are doing reflections. A reflection is still a non-rigid motion. A reflection is going to be a flip. Translation's a slide. A reflection is a flip over the line of reflection. Each point in its image are the same distance from the line of reflection. A reflection is an example of what kind of motion? Rigid, because it preserves congruency. Common lines of reflection that we're going to go over today is reflecting over the x-axis, reflecting over the y-axis. A vertical or horizontal line in the form of x equals a number or y equals a number. And then we're also going to do our diagonals, y equals x and y equals negative x. Okay, those are the 6 different lines we are going to reflect over. Our y-axis, our x-axis, and then just any vertical line, which is an x equal, any horizontal line, which is y equals, and then our linear parent function, y equals x, and then the inverse of our parent function, y equals negative x. Okay? So, on these, does it have to tell you what you're reflecting over? Yes. Okay, so let's start with plotting our points. -4, 2, 4, 7, and 5, 1. Okay, so we are going to reflect over this x-axis. So how far away is point A from the x-axis? It's 2 above it, so now I'm going to go 2 below it. So there's your A prime. My B is how far away from the x-axis? So now I'm going to go, and my C is, so 1 below it. Do you see what it says or means whenever it says they are all the same distance away from the line of reflection, just on the opposite side? Okay, so let's write what our ordered pairs are. What's A prime? -4, -2. What's B prime? What's C prime? Okay, so we're going to write a little rule over to the side. Okay? When you are reflecting over the x-axis, your xy becomes What? Compare the A to the A prime. What stayed the same? The X stayed X. What changed? Y became the opposite sign, right? So it's just X comma negative Y. So if you're reflecting over the x-axis, all you do is you change the y value to the opposite sign. Okay? What do you think is going to happen if we reflect over the y-axis? Instead of it being x, y, the rule is going to become negative xy. Okay? So on this next one, we are going to plot the points, but then on the later ones, we'll use the rule. Okay? So let's plot our PQRS. Okay, so this time we're reflecting over the y-axis. So how far away is my P from the y-axis? So it's going 1 to the left. That's your P prime. How far away is Q from the y-axis? So it's going 2 to the left. That's your Q prime. How far away is R? So 8 away on the left. And then what about S? 7 away on the left. Now guys, the nice thing is we are going to give you these rules. So like how we're telling you if you reflect over the x-axis, if you reflect over the y-axis, we are giving you those on your test. Okay? So P prime is negative 1, 2. Q prime is, R prime is, and S prime is. Okay, so do we think we can now do these just using the rule without graphing? Okay, so it's super important to make sure you pay attention to where you are reflecting over. We're reflecting over the y-axis, so we're going to use this formula, meaning just the x is going to become the opposite sign. So where's my F prime going to be? 5, negative 2. Where's my G prime going to be? Where's my H prime going to be? You can't take the opposite or the negative of a 0, so 0 just stays 0. And then what about I prime? What is it? 8, negative 6. Okay. Then when we reflect over the x-axis, just the y sign is changed. So what's my W prime going to be? Negative 2, 4. What's x prime? 1, 2. What's y prime? 4, 4. And what is z prime? Do we like just using the rule? Saves a lot of time, right? So like I said, your test is 31 questions, but you don't have to graph them if you don't want. If you have extra time, do you think it would be a good idea to plot the points and make sure that, yes, you're reflecting over the correct axis? Yes. Okay. When we come back from lunch, we are going to then reflect over other vertical and other horizontal lines, okay? Okay, so these we're not really going to be able to just use a formula for. We are, in fact, going to have to plot the pre-image. So let's plot triangle JKL. So 1, negative 1, 2, 3, and 3, negative 2. Okay, then the line we are reflecting it over is x equals 4. Do Do y'all remember back from Algebra 1 your Hoy and Vux acronym? Most teachers use it. I don't know. Maybe you've forgotten. But Hoy means horizontal lines have a zero slope and are written as y equals a number. That's where Hoy comes from, H-O-Y. Horizontal lines have a zero slope and the equation is y equals a number. Vux is vertical lines have an undefined slope and they're written as x equals a number. So if I have x equals 4, is that going to be a Hoy or a Vux? It's a Vux because it's x. Vux ends in an x, so this is Vux, meaning it's a vertical line. So I'm going to go on the x-axis, put a line or a point at 4. And there is my vertical line I am reflecting over. So how far away from how far away is point, we'll do J first, from the line? 3 away, so 3 the other way. K is 2 away. And L is 1 away. Notice when we're reflecting over our vertical line, did the y values change? No. K prime is just now at 1, 2, 3, 4, 5, 6, 3. K, that's one we just did. J is 1, 2, 3, 4, 5, 6, -1. Did I do something wrong? Did I count wrong? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yes, J is at 7. Sorry. 7, -1. And L, 1, 2, 3, 4, 5, -2. So again, notice how the y value stayed the same. We just changed the x values. Did you just add 4 to the x values? No. Okay, so that's why on these, you need to actually graph the pre-image, draw your line that is your line of reflection, and then reflect the image. Okay, so let's plot our points. R, S, T, and U. The line we are reflecting over is x equals -1. So I'm going to go on the x-axis, put a dot at -1, and since it's x equals, it's a vertical line. So how far away is R from that vertical line? So go 1 the other direction. What about S? It's 6 away. T is 7 away. Notice how I'm not changing the y values, just the x values. So then when we write our ordered pairs, R is now at -2, 3. S is at -7, 4. T is at -8, -1. And U is at -3, -2. So again, on your test, I would strongly encourage using the graph for these. Okay? The other ones, it's easy just to use a rule. There's not really a rule for this. Okay? It's much easier to visualize. Now let's do our y equals lines. Okay? Again, plot your original points. So this one is a HOI because it says y equals 2. So go on the y-axis, put it out at 2, and it's a horizontal line. So my C is 1, 2, 3, 4, 5 below it, so I'm going 1, 2, 3, 4, 5 above it to get my C prime. D is 1, 2 below it, so go 1, 2 above it. I don't think I did my C far enough. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Up. There's my C, not this point. F is 1, 2, 3, 4, 5 below. 1, 2, 3, 4, 5 above. E is 1 below, so E prime is 1 above. So we're going to write our ordered pairs. C is negative 4, 8. This time the X values aren't changing, just the Y values are changing. So my D is negative 2, 4. My E is 6, 3. And my F is 4, 7. Do we think we can do number 8 on our own?
Yeah.
Sure. Do number 8 on your own, guys. Put your pencils down when you're done with this, guys, so I know you're done, please. So my M prime should be at negative 6, negative 2. My N prime is negative 1, negative 4. And my P prime is negative 2, negative 2. Good? Okay. How many of us would rather go back to ones that we can use rules and we don't actually have to graph? We got to use rules for the next ones. Reflecting over y equals x and y equals negative x. So for the y equals x line, and I put x equals y. For the y equals x line, my ordered pair xy is going to become yx. You're literally just flip-flopping the x and the y values. Then for my y equals negative x, my xy is going to become negative y, negative x. Good? We'll do one where we, or do y'all just want to use the rule? I'm giving you the rule on the test. Are we good if we just use the rule? Okay. So, this first one we are reflecting it over y equals x. So we're going to use the y equals x rule. That just means we flip-flop the ordered pair. So what's x prime going to be at? Negative 2, negative 5. What's y prime at? What's z prime at? Do we like that? Now, we are going to graph just one, just so we can see what it looks like to reflect over y equals x. So your y equals x line goes through the origin, and it just goes from corner to corner. So my new ones would be what did I do wrong?
It doesn't look right.
It does not. Oh, I did -5, not -2. -5. Yes, that looked way wrong. There we go. My x prime was in the wrong spot. There we go. Now, does that look like it's a mirror image over this line?
Yeah.
Okay. Let's just keep using the rule. I don't really feel like graphing all these. Okay, next one we are again reflecting over y equals x, which means you are just flip-flopping the ordered pairs. So g prime would be at what? H prime is at what? I prime. And j prime. You are literally just flip-flopping the ordered pairs. Good? Now, reflecting over y equals -x. Your rule for reflecting over y equals -x from the front was xy becomes -y, -x. Okay, so you flip-flop them and you change both signs. So what would A be at? -3, +1. What would B be at? -6, 0. What would C prime be at? And D prime. Okay, what's S prime? T prime. And T prime. For -3. Good? Okay, now we have to find what the rule is. Okay, where are we reflecting over? Okay. So, looking at this first one, where do you think we're reflecting over? The y-axis. If you look, is point K 1, 2, 3 away, and K prime is 1, 2, 3 away? Yes. So it's the y-axis. Okay, what about number 14? Y equals -x, because your line of reflection would be right here, which is your parent function, but the opposite of it, so y equals -x. Okay, what about 15? So it's a vertical line. Vertical lines are vexes, because vertical lines, VUX means it's x equals, where does it hit the x-axis? -3. Okay, what about 16? 16 looks kind of tricky because it's like reflected on each other. It's just the x-axis, guys. Okay, what about 17? Y equals 1. And 18? Y equals x. Do we like those? Pretty easy. Is there more? Yes, we're finishing the packet today, guys. I know. Nope. We are waiting. Yeah, it's only, well, 3 pages. If you're looking only at the
I was looking at how many pages of the
number of pages, not sides of pages. Okay, so next we are going on to a rotation. A rotation is just a turn about a fixed point called the center of rotation. Guys, we are going to do this pretty easy and straightforward. The figure rotates at a specific angle and direction. Though the figure can rotate around any fixed point, normally the center of rotation is going to be, what do we think? The what? It's a point. The origin, 0, 0. That's the only ones we're doing. Okay, they're all rotating about the origin. Okay, so they all follow a rule. Okay, we're always going counterclockwise. Well, if you do 180, isn't 180 counterclockwise and 180 clockwise going to give you the same thing? Yeah. If I turn my paper this way, counterclockwise, 180, that's the same as turning my paper this way, 180. So that's why it doesn't matter. Okay, but counterclockwise, we're going to follow the rule. My point xy will become point negative y x. So you're flip-flopping them and changing the y sign. For 180, you don't flip-flop anything, we're just changing the signs. And for 270, we're flip-flopping them, but changing the x sign. Again, you will be given these rules on your test. Okay? Today's lesson is taking us a little bit longer. Are we good not graphing any of these?
Yep.
Yeah.
And just using the rule?
Yeah.
Okay. If you want to, after we're done, you can always go back and graph some of them to see what it actually looks like. But if you look, right here, it gives you an example of what your graph would look if you rotate 90 degrees, if you rotate 180 degrees, and if you rotate 270 degrees. Okay? So all we're going to do, use our rule. So 90 degrees counterclockwise means my points are going to become negative y, comma x. Flip-flop the ordered pair and change the y value. So what's my new ordered pair? Negative 7, 2. Flip-flop them and the 7 becomes negative. What about b prime? What is it? Negative 5, 6. Very good. And then c prime? Negative 1, 4. Great job. 180 means we become negative x, negative y. So what's p prime? What's q prime? What's prime? And what's s prime? Good? Do we like using the rules? Okay, 270 degrees counterclockwise. That means we're going to become y negative x. So we flip-flop them, the next value changes. So what's the j? 4, negative 3. K prime? 4, negative 6. L prime? M prime? 180 degrees means it becomes negative x, negative y. So what's my x prime? Y prime? Z prime? Good? 270 counterclockwise means it's y negative x. So what's my C prime? 5, 5. D prime. E prime. And F prime. 90 counterclockwise means we are what? What is it? I just trusted you. 90 is negative yx. That's right. Okay, so T prime becomes, do what? 1, negative 3. What's U? U prime, I should be saying, sorry. What's V prime? 8, negative 2. And what's W prime? Okay, 180 just becomes negative x, negative y. Just change the signs. So what's M prime? N prime. O prime. P prime. There we go. 270 is y negative x. So G prime, H prime, I prime. Good? Guys, can we jump to the clockwise ones? Are we okay with all the counterclockwise ones? We're good with using the rules? Okay, let's jump to the last two. Sometimes it might say clockwise. It says hint. Think of the corresponding counterclockwise rotation and apply that rule. So if I'm going 90 degrees clockwise, that would be equivalent to what? 270 counterclockwise. So that means this is 270 degrees counterclockwise. What's your 270 degree counterclockwise rule? The 270 y negative x. I'm on number 13. So L prime, M prime, N prime. Okay, so 270 clockwise would put me here, which is 90 degrees counterclockwise. And your 90 degree counterclockwise rule is negative yx. Guys, would they ever tell you 180 clockwise or counterclockwise?
Nope.
No, because it's the same thing no matter which way you go. Okay, so what's my G prime? Negative 2 what? Negative 2, negative 7. What's my H prime? I prime. And J prime. Yay, we are done with this ridiculously long packet. Good? What are we doing next, class, guys? Reviewing. Then we are testing next Monday and Tuesday, okay?